So I have used many game frameworks in my time, and none of them has done exactly what I need them to. So a couple months ago, I built my own game framework, and it worked well, and I used it for many different things. But since I never compressed it into a jar, I always ended up editing the source just a little. As I was only copying and pasting it, so that after a couple months of this framework, I had like 20 different versions. And I've decided to completely rewrite it all, take all the expertise from different versions and put it all into one thing. So it is a very extremely thin layer around around the JavaX Swing library and AWT Abstract Windowing Toolkit library. It's a thin layer, and all it does is extremely rapid refreshes on a paintable panel. That's all it does. And there's many different things you can do with that. And this is my progress for my first couple days in it. The framework is called Dodo Games, and I have and every class from the library is prefixed by DG, which makes it rather easy to see if it's from the library or not. And so I'm going to run it and show you what I have so far. As you can see, we're doing extremely rapid repaints on a panel in a window. That's all it is. And we have many different structures that represent, and every one of those moving things is a different structure. Is its own class. We have a DG game right here, which all that does is it extends JPanel, implements some listeners, has some static but not final settings so you can edit them at any time, and it has a list of entities and keys down. An entity is basically something that can interact with other entities in the game. That's all it is. And we have a shape, which is the basis for occlusion detection. A shape is a very simple abstract class that can draw itself to a graphics object, and has a width, a height, an x and a y, or a position, and can check if it collides with another shape, and it also checks if a point is inside it. That's all it does. And it's an abstract class, which means that subclasses have to implement point inside, get W, get H, collide, and draw methods. There's a subclass called circle that represents a circle shape. A subclass called shape rect that represents a rectangle shape. A square is a rectangle, but a rectangle is not a square. So don't worry if you want a square. And we also have entities, which is the main part of this framework. So an entity already looks complicated, doesn't it? So it has every entity has a reference to the game that's running right now, or currently, a shape, a friction, acceleration, velocity, maximum acceleration, and maximum friction, which represent friction, acceleration, velocity, and bounding values for those. It can draw debug, which it can draw its shape, it can draw its velocity, acceleration, and friction, and it can also update and bound everything. And this physics model is very simple. Velocity is velocity plus acceleration every frame. Acceleration is acceleration minus friction every frame. The position is position plus velocity every frame, and and velocity is bounded with max velocity, and acceleration is bounded with maximum acceleration, and friction is bounded with maximum friction. We have an entity Mr., which all it does is it has a sprite sheet, which, as you can see, is a player, a goblin, wolf, something, skeleton, something, and something. And it just it chooses a random one and does that. And these are represented by 0, 1, 2, 3, 4, 5, and so on, 0 through 9 inclusive. And so right here, we are making a list of all the frames that are going to be in this animation. Like, is it 0, 1, 2, 3, or is it just 0, or what it is. And right here we are getting a random integer 0 through 9 inclusive, and adding that to the frame list. And then initializing an animation named anim that loops with starting at frame index at 0 in the frame index. It has the sprite sheet path is characters 32 by 32 .png. It has the frame list. Sprites in row is 10, sprite width is 16, and sprite height is 16, and updates per frame is 60. And that's it. And so right here we're adding from 0 to 2, which is 0 and 1. We are adding a random integer. However, we can 0, 1, 2, 3, 4. What that means is every second it will go to the next one and it will loop. So, and you have an update. We add a random number to the velocity. We call super.updates for physics. We check if we went out of bounds. If so, we call the reset method, which puts us back in the center. We check we set the velocity back to 0, 0. So if we run this, you can see we have, and they're changing synchronously because they're all on the exact same timer. However, we can do this, which gives us, say we wanted, so this is interesting. What it will give us is it will start with as the orange guy, and then it will have 2 frames which are random. See, you can see now it's orange, random 1, random 2, orange, random 1, random 2, orange, that, and it just goes on and on. We set loop to false. Again, this is, I don't know what will happen. Yes, see, we got some exceptions. As I said, this framework is definitely not done yet, and so yeah, I have this will do an animation really easily. Right here we draw our animation with our shape and the game. I've built an entity blob which just follows the mouse given a offset X and offset Y. That's all it does. And in the game itself, right here we have N1 and N2. N1 is the number of blobs, and N2 is the number of misters. So if we set the number of blobs to 1,000, as you can see, we have added the blobs to the list of entities last, so the blobs come after the entities. The blobs are shown after the misters, which means that the blobs are above the misters in a 3-dimensional environment. You could see how the misters appear unfocused and the blobs appear focused, at least when the misters are all the same color. And we can do fun things like 100,000, which, as you can see, is very slow. Look at all those misters. And when they go out of bounds, they reincarnate at the very center. And something that's very interesting to see is what happens when we reset the entity or the mister, we don't reset its velocity. It means that they get faster and faster and faster. Which, as you can see in the very... Darn, I need to turn off these blobs, they're annoying. So if we... So with 1,000 misters, and if we turn off the random, they're always player, then once they get fast enough, in every frame, at least one mister will get reincarnated at the center, which means that every frame there will be at least one mister just sitting there at the end of it. Which in this single mister is not the same one. It is actually it's a different one every frame almost. Chances of one mister staying in the same place for 3,500 frames now is like 1 over a million. So I'm going to assume that it's not the same one. And yeah, this is the progress for this game framework so far. It's coming along. I'm gonna be posting it to GitHub soon. There should be a link in the description. Yeah, thank you for watching.